2's complement arithmetic involves performing addition and subtraction operations on binary numbers, represented in 2's complement form. In this slide, we see an example of a binary addition. The binary number 1101 is added to 0110, resulting in 0011. 2's complement is a method used to represent signed integers, both positive and negative, in binary format. The most significant bit, which is the leftmost bit, indicates the sign of the number. A 0 in the most significant bit typically represents a positive number, while a 1 indicates a negative number. The 2's complement of a binary number is calculated by first finding the 1's complement, which involves inverting all the bits, changing 1's to 0's and 0's to 1's, and then adding 1 to the result. Therefore, 2's complement equals 1's complement plus 1. Let's walk through an example of converting a binary number to its 2's complement representation. Starting with the original binary number 0110, we first find its 1's complement by inverting each bit. This gives us 1001. Next, to find the 2's complement, we add 1 to the 1's complement. So 1001 plus 1 equals 1010. Therefore, the 2's complement of 0110 is 1010. When performing addition with 2's complement numbers, there are two main rules to keep in mind. Rule number 1 states that you should add the binary numbers normally, just as you would with regular binary addition. If there is a final carry, simply ignore it. Rule number 2 says that it is crucial to check for overflow. Overflow occurs when the result of the addition is too large to be represented with the available number of bits, and the sign bits of the numbers being added must be consistent with the sign bit of the result to ensure accuracy. Let's look at an addition example using 2's complement representation. We're adding positive 3 and positive 5. In binary, positive 3 is represented as 0011, and positive 5 is represented as 0101. Adding these two numbers together, we get 1000, which represents positive 8. Note that the final carry is ignored in 2's complement addition. In 2's complement arithmetic, subtraction is performed by adding the 2's complement of the subtrahend to the minuend. In other words, instead of subtracting a number, you add its 2's complement. Therefore, a minus b is equal to a plus the 2's complement of b. Let's walk through a subtraction example. We're subtracting positive 3 from positive 7. First, we need to find the 2's complement of positive 3. Positive 3 in binary is 0011. To find its 2's complement, we first invert the bits to get 1100. Then we add 1 to get 1101. Next, we add positive 7, which is 0111, to the 2's complement of positive 3, which is 1101. Adding these two numbers together, we get 0100, which represents positive 4. Overflow occurs when the result of an arithmetic operation exceeds the range of values that can be represented with the available number of bits. In 2's complement arithmetic, overflow can be detected by observing the signs of the operands and the result. Positive overflow occurs when two positive numbers produce a negative result. For example, 0xxx plus 0xxx equals 1xxx, where x represents a binary digit. Negative overflow occurs when two negative numbers produce a positive result. For example, 1xxx plus 1xxx equals 0xxx. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.